Hello everyone. I'm Ashish Das. I'm a solution architect. Also, I have interest on this Google Kubernetes Engine and other open source services and products as well. Okay, so in this session, we will look at one of the most popular services, which is used for application modernization. That is Google Kubernetes Engine. Okay, so in one of our previous session, we have talked about container orchestration. Yeah. And obviously we discussed a little bit about Kubernetes. Anyway, so let me just recap a little bit about containers. Uh, a container is a more efficient way to resolve the library and application environment specific dependency problem. Okay. So that is by implementing abstraction at the level of the application and its dependencies. Yeah. So we don't have to virtualize the entire machine or even the entire operating system, but just the user space. The user space is all of the code that resides inside above the kernel, and it includes application and their dependencies as well. So basically, containers are isolated user space for running application code. Yeah, containers are lightweight because they don't carry a full operating system. They can be scheduled or integrated tightly with underlying system as well. And containers can be created and shut down very quickly. As we think uh, in the Linux operating system, there are different processes, right? So how easy it is to stop and start a process. It is similar to that. So basically, container can be created and shut down in as quick as stopping and starting a Linux or operating system process, rather than booting an entire VM and initializing an operating system of the each application. Yeah. So today's the agenda is, so we'll just discuss about why GKE. Yeah, we'll just talk a little bit about maybe the differentiation between Kubernetes and GKE, and we'll have a demo in Google Cloud Platform, that is creation of a cluster and deployment. Yeah. So now, what is Kubernetes? Yeah, suppose your organization has really, come up with an idea of containers as a part of the application modernization program. Now, because containers are lean, what happens is everybody likes that, right? So now our your co-workers are also creating them in a numbers exceeding say 500 or 1000. Yeah. So now the application is running in the containers, and we need to communicate, and they need to communicate over the network. But we don't have a network tool that containers will find each other, or how they will gonna communicate with each other. So for that purpose we need help, right? So how can we manage the container infrastructure better? So the solution is Kubernetes. So Kubernetes is basically an open source platform that helps us orchestrate and manage our container infrastructure on premise or in the cloud, and it provides cluster management as well. Yeah. So whatever workload we want to deploy, we need to deploy into a cluster, and Kubernetes allows us to create cluster, also manage them, including upgradation of the cluster. And in a single cluster we can have different types of virtual machine. Yeah, so different nodes, we can say, in the cluster that can have a different hardware and software configuration. Similarly, Kubernetes also it provides with all the important features that we expect in as a container orchestration tool. For an example, auto scaling, service discovery, load balancing, self healing, etc. So now, what is GKE? GKE is basically Google Cloud's managed service offering for Kubernetes. Yeah. So why do people choose GKE? Yeah, we all know that Kubernetes is powerful, but managing the infrastructure is a full-time job. Yeah, there are a lot of steps involved in that. So what if uh, you have begun asking Kubernetes in your environment, but the infrastructure has become a burden to maintain. Is there anything that Google can help with inside Google Cloud Platform? Yes, the answer is Google Cloud offers a managed Kubernetes solution called Google Kubernetes Engine or GKE. So uh, GKE is yeah, it is managed Kubernetes service on Google infrastructure. So GKE helps you to mostly deploy, manage, scale uh, at Kubernetes environment for our containerized application on Google Cloud. And specifically, GKE is a component of the Google Cloud Compute offerings. Yeah, it makes it easy to bring the Kubernetes workloads into the into our cloud platform. Yeah, obviously. So there are few features in the GKE. So it is fully managed. Yeah, which means we don't have to provision the underlying resources. Yeah, it has a container optimized operating system to run our workloads. So these operating systems are basically maintained by Google and are optimized to scale quickly with a minimal resource footprint. Also, we can attach any volumes such as any persistent disk or local SSD with the nodes that is a part of the cluster. Yeah. When we use GKE, we start by directing the service into to instantiate a Kubernetes system for the deployment. I mean for the service, right? So this is called a cluster. So GKE's auto upgrade feature, yeah, auto upgrade feature is what? Auto upgrade features can be enabled to ensure that our clusters are always automatically upgraded with the latest version of the Kubernetes. And these virtual machines that host the containers in a GKE cluster, those are called what? Nodes. So if the let's suppose it let's suppose few of the nodes are found unhealthy. I mean those are certain errors are there. So what it will do, GKE will automatically drain the code. So that means it will cause the workloads to gracefully exit, and it will recreate the node. Yeah, just as Kubernetes supports scaling workloads, similarly GKE also it supports scaling the cluster itself. Yeah. uh, it has an yeah, okay. So why is this cluster scaling is important? So imagine a scenario. Let's suppose we are running with multiple microservices in a Kubernetes cluster, and these microservices might be running on a different node on the of the cluster. So now pod auto scaling deals with the increasing the number of the instances of the specific microservices. So if I want to increase the number of instances of microservice A, then I would need to increase the number of pods belonging to microservice A that are running, right? So now, however, if I would want to increase the number of instances where the microservice A run itself, then I would also need to increase the number of nodes in the Kubernetes cluster, and that is where we need to go for the cluster auto scaling. Yeah, so as we keep increasing the number of instances of microservices, we it need to be part of the auto scaling and cluster auto scaling as well. Yeah, so this is what cluster auto scaling. Similarly, GKE it has the features for seamless integrations with other Google cloud products for such as cloud build and cloud registry. So this is basically, it allows us to automate the deployment using the private container images that we have sometimes the organization have securely stored in the container registry. Okay, it also has Google's identity and access management, which allows control access through the accounts and permissions and role permissions basically. Also it integrates with cloud logging and cloud monitoring. Yeah, so we can easily enable them with very simple configuration so that we can have logs and different matrices around the Kubernetes cluster. Similarly, GKE is integrated with Google Virtual Private Cloud to make use of Google Cloud's networking features as well. Yeah. So, and finally, Kubernetes has a dashboard, which is not so easy, obviously, to set it up. However, we have in the Google Cloud Platform, we have Cloud Console. Okay, so and that Cloud Console is it. We don't have to manage anything. It is a powerful tool basically to get all the details about the GKE. So basically, what is the cluster information, the other monitoring related information. So we're gonna see this while we're creating a demo. Yeah, so basically as a part of demo, these are the 4 steps we want to execute. Yeah, so before even GKE cluster, how in an enterprise environment it works is obviously once the developer create a file, then obviously they build a container image through maybe some Docker file or some other image file, and then they need to create a GKE cluster. Then they need to deploy that sample app into the cluster. Then the scalability is also it has to be managed, whether it is an auto scaling or manual scaling for the deployment. And finally, that deployment has to be exposed to the internet. Yeah, so let's move to the Google Cloud Platform. Yeah, so let me just create one project for that. So I'll call it AD Cube project. Let me create it. Yeah, my project is created. So let me now select this project. Yeah, so now let's go to Kubernetes Engine. Yeah, so before we want to create a cluster, we always have to enable the Kubernetes Engine API. So similarly, I mean, just like while creating the compute engine, we need to enable this compute engine API. Similarly, for Kubernetes, while to creating cluster in GKE, we need to enable this Kubernetes Engine API. So it's basically builds and manages container-based application powered by this open source Kubernetes technology. Yeah, let me just enable it. It will just take a few seconds. It is taking longer than usual. Okay, so while it is creating, enabling this Kubernetes Engine API. Yeah, I think it create. Yeah, okay. So we can create the Kubernetes cluster from this Cloud Console. Yeah, and also from this Cloud Shell. Yeah. So first, let's create this from this console, and then later we'll activate this Cloud Shell. We're gonna try to create from there. Yeah. So we'll gonna click on create. Yeah, so now if you'll see, we have two options. One is standard, one is autopilot. So standard is something that we have to manage the underlying infrastructure, including the configuration of the individual nodes. Yeah. And autopilot is basically GKE manages the underlying infrastructure such as node configuration, auto scaling, auto upgrade, baseline security configuration, and baseline networking configuration. Yeah, so all this has been automatically created, managed. So for this demo purpose, let me just stick to the standard. Yeah, let me just give it name. Yeah, so we have to select a location type, whether it's a zonal or regional. So if we select a zonal one, so basically the control plane of this particular cluster, it will be in this particular zone, whatever we'll select. Yeah, we can also select multiple zone. If we'll select this, so yeah, so this is this US Central -C is where this control plane will be there. And if we want to select the other zones, it will have, yeah, it will increase the availability. Basically, in this US Central -A and US Central -B, our other nodes like worker nodes will be there. But the control plane, it will be there at -C. So for the demo purpose, let me select single zone. So and here my control plane and even the worker nodes will be there in US Central C. Other thing I'll just, yeah, so other options are control plane version. So here there are two options: static version and release channel. So static version is obviously if you want a specific version requirement is there, then you go for this. But recommended is this release channel, so that it will gonna automatically take. Anyway, we're gonna click create. It will take some time. Yeah, you can see. Yeah. Anyway, it will take some time to create all the nodes and the underlying infrastructure. Okay, so while it is creating, let's discuss about why actually we need. I mean, would Google recommend running the production workload on autopilot? So autopilot basically provides a default configuration that has benefits. What benefits? We have cost efficiency. We have automation, we have improved security, posture, and reliability. So how cost efficiency? Now we only pay for the compute resources, yeah, that the workload use while running. So we don't pay the unused capacity on the nodes, system pods, operating system cost, or unscheduled workloads, etc. Similarly, for automation, Google manages the nodes, creating new node for the apps and configuration automatically, automatic upgrade and repairs. And also, GK automatically scales the nodes and workload based on the traffic. And improved security also, autopilot clusters enable many GKI security settings and Kubernetes best practices by default. So GKE automatically applies security patches to the nodes when available. Yeah, so this is why we need to select this GKE autopilot. Also, there are other features such as node pools, scheduling, resource management, version management. So all these also features are there. Yeah, it is taking some time. So you can see that number of nodes is 3, but the total vCPU and memory is 0. So that is because it is not yet fully created. This is being created. You can see there is a message here. So once it is fully created, there would be something here in the total vCPU and total memory. Yeah, so it took quite a bit of time to create the cluster. So now we can see the cluster is created. We can click on this cluster name. So this is where you can find all the details: name, AAD cluster 1, location, journal, where is the control plane is there, where the default node is there, that is US Central C, or the total size is this. Okay, so that means uh, if we'll want to check in the compute engine also, you will see 3 nodes. That means 3 compute engine instances are created, and that is used by GKE cluster 1 default pool. Yeah, so by default, in the standard mode of operation, 3 nodes are already been created. Yeah. So now let's go to Kubernetes Engine. So we want to deploy a workload. Yeah. So we can see there is no workload here. So what is this GKE workload? GKE, basically we know that GKE works with containerized application. So these are application packaged into platform independent isolated user space instances. For an example, by using Docker, right? So in GKE and Kubernetes, these containers, whether for applications or batch jobs or other purpose, are collectively called as workload. So before we deploy a workload on GKE cluster, we must first package this workload into a container. Yeah. Uh, yeah, we will just gonna create clusters. So let's connect to this cluster. So how, let's use this Cloud Shell now. Click on Cloud Shell, maximize the window. Yeah, let's set the project ID. This is our project ID. Let's authorize. Now I'm connected to the Cloud Shell. Yeah, so now I need to okay, cluster is created. I can also create the cluster via from this command. For an example, gcloud, the command is container clusters uh, create. So create is the command to create a cluster. Okay, so now we don't want to create, we already created. We want to connect this to this cluster and create some deployment and workload. Okay, so for connect, this is the command. So let's directly put that command here. gcloud container cluster get credentials. Yeah, so that is how we're gonna connect to this particular cluster name and zone and project. Yeah, this is the command. Yeah, it's generated. Okay, so now we want to create a deployment. To create a deployment, the command is normal Kubernetes command, which is kubectl. Kubectl create deployment. We don't want any typo here, otherwise it will not work. So let's give a name, hello server. Okay, we need to give an image. Either in the first 2 steps, what we discussed is, okay, we need to create a image, maybe via Docker, or it can be there in a public uh, in public, or it can be there in the artifact registry inside the Google Cloud. Okay, so we will use a image which is already been created by Google for these training purposes. So yeah, so we will use that particular image which is there in the artifact registry inside Google Cloud. So hyphen image. So we'll give the location. This is where I found that location. US Docker package. This in the artifact registry. Okay. 1.0. Command not found. Why? What happened? Okay, double B. There is a typo here. Deployment, hello server, this, yeah, let's try. Yes, hello server is created. So now the server is created. So you will see the workload here. You can see the hello server is created. Yeah, we want to, but this is now isolated from the public internet. It is only there inside Google Cloud. So we want to expose it. Yeah. So the command is again kubectl expose deployment. Our name is hello server, right? Hyphen type is load balancer. Hyphen port is 80. Hyphen target port. So target hyphen port is 8080. Yeah, let's try. Yes, this is now exposed. Let's inspect whether it is there or not. The command is kubectl get pods. Pods are smallest deployment inside a Kubernetes. Yeah, so it is up and running. Let's check the services. Kubectl get service. Yeah, we can see there is a cluster and the hello server, which is exposed to the external internet via this load balancer. And this external IP is pending. So this external IP will be assigned by Google. It will take a few seconds. Yeah. So let's try again. Get service. Yeah. Now you can say the external IP is present. Yeah. So now, if we want to check, what do you want to do? Curl this particular IP. Then our port is 8080 slash hello server. Let's try. Yeah. So this is our link. So if you want to hit it from the browser, it will gonna give this host name. So now our workload is up and running. Yeah, so this is a very basic uh, deployment that that has 3 nodes and a single pod. Okay, so now let's suppose I wanted to uh, scale it a little bit. I have only one replica. I wanted to, let's suppose, give it 3 replica. So now what the command? Kubectl kubectl scale deployment hello server hyphen replica equal to 3. Yeah. So now let's try this. Find the services. Get service. Get pods. Yeah, we can see there are 3 replica running. So now let's curl. Wanted to see. Yeah. So let's. So because there are now 3 replicas, so now when we'll hit it from the external environment, it will gonna randomly depending on like the load or etc. So it will gonna redirect to the different server or different pods. Okay, so now when we hit it, it gave us this ZWM4P, which is this one. So now let's suppose that we'll hit again ZW. Okay, again the same one. Now you can see there is a different server it hit ZWLZS, which is this one. The same thing can be found out if we'll do this from the external environment. Yeah, this ZWZS. Yeah, you can see this is changing. Yeah, you can see. Yeah, so till now we just deployed one deployment and then we had scaled it manually. But still we are not happy because this is not the power of GKE yet. So GKE, it will gonna automatically scale it up, the pods as well as the clusters. So how to do that? Gcloud. Okay, so before that, if I want to change my size of the cluster, how to do that? The command is gcloud container clusters resize. Now my name of the cluster, what is this? Anyway, cluster resizing, I can do it from here as well. AD cluster 1. Hyphen node pool. Hyphen number of nodes is, I want to decrease it to zone US central -C. What happened? Is the zone information is not correct, I guess. So US central 1-C. Yeah, here default pool. Node pool name is default pool. Yeah, we want to resize. Now my cluster will be resized. It will gonna again take some time. Yeah, so resizing of my cluster is done. So the nodes are now reduced to 2. Let's check it. You can see it here. If you go to clusters, see here. Now if I go to compute engine, yeah, you can see 2 nodes are there, 2 instances, VM instances are there. Yeah, so let's go back to GKE. Here the workloads are there. Here services and ingresses, external load balancer information is there. So if you want to, let's suppose, yeah, here node information you can see, storage, if the standard premium, so all this information we can see. There is observability. So basically the events and integration information. So all this information is available in this particular dashboard. Logs will be also there. Uh, yeah, so these are the logs. So all this information is readily available. It's already by default taken care by GKE. Yeah, so now if I want to auto scale, so how to auto scale? So till now we did a manual scaling. So if you want to auto scale, cube kettle auto scale deployment, deployment our deployment name is hello server hyphen hyphen. I want the maximum replica to be 4. And when this auto scaling will happen, when my CPU percent utilization percent is let's say 70%. Yeah. So as soon as I enter this command auto scale deployment, so what will happen internally is this: there is a HPA, so basically horizontal pod auto scaler. That configuration will be enabled. So whenever the CPU utilization is will reach at least 70%, now my there will be a scale in the pod, and similarly the cluster will also be uh, configured for auto scaling. Yeah, so there are other features also, so that we will gonna cover it in the later sessions. So for today, I think this is what I wanted to cover. So what we learned? We learned about uh, GKE. We created a cluster, standard cluster. We understood a little bit differences about the standard and autopilot mode. Then we created a sample deployment from an already created uh, image. So in the next step, probably we're gonna create this image from a Docker file by in the in the session, and then we're gonna deploy it. Yeah. So now all my resources are those are live. So the when the resources are getting utilized, so there will be a charge or billing will come. So it is a cost to me. So yeah. So as soon as our training is over, we should not forget to delete all our resources. Yeah, so how to clean up those resources? Cube delete. service hello server. Yeah, it is deleted. It's gonna take a little bit of time. Similarly, we need to delete the cluster as well. Otherwise, the nodes will be there and there will be cost for the virtual machines as well. Yeah, so I'll delete the cluster once. Yeah, I think the service is deleted. So I'll delete the cluster as well. Gcloud container clusters delete. What is our cluster name? AD cluster -1 zone is US -central 1-C. Yes, we want to delete. Yes, it will take some time to delete again. Yeah, if you have any question, any suggestion, you can contact us on contact@imesh.ai. Yeah, thank you.